Scalar and vector quantities differ primarily in terms of their characteristics and how they are represented. A scalar quantity is defined by having only magnitude, size, and no direction. Scalars are typically used to describe simple measurements that do not depend on any particular direction. For example, quantities like speed, mass, temperature, time, and energy are scalar because they can be fully described with just a numerical value and a unit, such as 5 kilograms or 30 seconds. Scalars follow the rules of ordinary algebra, making them straightforward to add, subtract, multiply, or divide. On the other hand, a vector quantity has both magnitude and direction. Vectors are used to represent quantities that depend on orientation or movement in space. Examples include velocity, displacement, force, and acceleration. A vector cannot be fully described without stating its direction alongside its magnitude, such as 10 meters per second to the north or 50 n at an angle of 30 degrees. Operations with vectors, such as addition or subtraction, require special techniques like the head-to-tail method or vector components because direction must be considered. In summary, scalars are simpler and only involve size, while vectors are more complex as they include both size and direction. The following are examples of scalar quantities: distance, mass, length, time, temperature, area, and so on. Also down below are the examples of vector quantities: displacement, velocity, acceleration, force, momentum. What you have to ask yourself is about the difference between displacement and distance. Also velocity and speed. Study the question below and give us the answer. The question is: velocity is speed, but speed is not velocity. Also, another question is: retardation is acceleration, explain.